and related items to him. Moving on now to the John Adam Fleming Medal, which is awarded for original research and technical leadership in geomagnetism, atmospheric electricity, aeronomy, space physics, and/or related sciences. The recipient was chosen for his path-breaking and fundamental experimental and theoretical contributions to the measurement and understanding of electric fields in Earth's space plasmas. Kindly welcome from the Space Sciences Lab and Physics Department, University of California, Berkeley, Forrest Mozer.
I guess I should first thank the AGU for providing the step that I can stand on so I can see. But I also want to thank the AGU and the Fleming Committee for the honor and the satisfaction of receiving the Fleming Medal. I accept it on behalf of the students, postdocs, and engineers who did the heavy lifting that got me here tonight. And I want to tell you a little bit about some of these people by telling you two stories of my career. In the 1960s, it was known that electrons in the Earth's radiation belt in Aurora were being accelerated locally. But the electric fields, which is the only element that could do this, were not measured and not well understood theoretically, in spite of many experimental attempts to measure such electric fields. It occurred to me that one might use Langmuir probe theory to put a bias current on a pair of spheres, separate the spheres, and measure their potential difference to determine the electric field. We tried this detection scheme for the first time on a sounding rocket flown from Andenes, Norway in October 1966, and we succeeded in making the first electric field measurements in space. My colleagues who helped with the instrument development and the data analysis at that time were Arne Pedersen, Ulf Fallesen, Carl Gunnar Feldhammer, Mike Kelly, and Paul Brewstone, great associates. This research continued at Berkeley, where I have been since that time, where we have flown sounding electric field experiments on very many sounding rockets and more than 100 electric field measuring balloons. Then, in 1976, we had the opportunity to fly a 3-axis double probe electric field experiment on an Air Force piggyback satellite called S-33. We made the first electric field measurements above the ionosphere on that satellite, and we observed extremely large parallel electric fields that we called electrostatic shocks, and that were responsible for accelerating the electrons that make the discrete aurora that you see in all of the pictures of aurora. Our team at that time included Mary Hudson, Bill Lotko, Bob Lysak, John Wygant, Cindy Cattell, Roy Torberg, Bob Ergen, and Gar Bering, all of whom went on to distinguished careers as faculty members at other universities, and all of whom did the real data analysis that allowed us to understand this complex electric field data measured for the first time. And last, I want to thank the group that made all of this seem worthwhile. My children, Todd, Mike, Dana, Laura, Sam, and HK. Thank you, kids. I love you.
Congratulations, Forrest. Next, we have the James B. McElwain